The third topic is mine. I'm Dr. Seung, Associate Professor at the Department of the Building and Real Estate in Korea Polytechnic University. My presentation topic is Immersive Virtual Reality Applications in Construction. Here is the content table of the contents. Okay, actually, I believe that now we are living in the age of the Metaverse because everyone talking about the Metaverse, especially including some immersive virtual reality. So the Metaverse is kind of some virtual reality space where the users can interact with each other or some interact with some computer-generated environment. And for the Metaverse application, I believe that the immersive virtual reality would be important role in creating the immersive some Metaverse experience. And recently, the head-mounted display test market is rapidly growing. So maybe in 5 or 10 years, maybe we're gonna have at least one HMD. Like everyone nowadays, we have a smartphone. Like maybe in 5 or 10 years later, maybe we're gonna have at least one HMD. And this the immersive virtual reality applications in construction. Actually, these days, the many construction companies are very interested in applying some these IVR technologies for some different application, including some design review, optimization, and the collaboration and the training. So actually, the IVR applications, there are some commercial applications that allow us to use VR technologies for the different purpose. Actually, in this research, actually, I have been interested in human factor issues in the IVR system because I believe that understanding some human factors while we are using the IVR system can help us some better design of the IVR system, and also the use of the IVR system can help some better understanding of the human factors as well. So the interaction between the human factors and some IVR system would be quite important research topic for the intuitive and the efficient use of the IVR system in the construction. So I've been working on this topic almost for 5 or 6 years. And of course, I cannot address all some remaining research questions, but so far here, this slide shows some of my research questions I've been working on. First, would IVR-based communication be effective from the construction project perspectives, or can IVR-based safety training can change some training safety behavior, and what would be the fidelity requirement of the IVR system? And how can IVR simulation be used to understand the workers' hazard recognition behavior? Let me briefly introduce my previous studies for each question one by one. The first, the effectiveness of the IVR-based communication. Recently, actually, due to the COVID-19, actually the virtual conferencing or some online a meeting is quite common. But I did this study almost 5 or 6 years ago. At the time, there was some software that allow us to go into the BIM model and then discuss with the others who are remotely located. So I wanted to evaluate whether this IVR-based remote communication would be as effective as some face-to-face communication. So that I did some experimental study because I've been interested in the human factor issues. So that I've used some experimental study involving some human subject. In this experiment, I split the two groups. One is the BIM-based some design collaboration tasks. Another one is the participant will join in the virtual environment that was created by using BIM, and then using the avatar, they can see each other. Actually, this is the avatar-mediated some environment, so that even though they are located in the different location, they can meet together in a virtual environment and both groups were given some similar tasks like determining the best design options for the specific project. So while they are doing this communication, I evaluated the communication effectiveness using these 5 measures: group discussion quality, communication appropriateness, and communication openness, richness, and accuracy. What I found was, first of all, mostly in terms of these 5 measures, face-to-face communication would be better, especially in terms of the appropriateness and the openness. The face-to-face communication would be better, but in terms of the richness, IVR-based communication is better, because that is why we are using the VR for the BIM-based design review, because the design information from the virtual environment can be more realistic, because we can feel the design, so that we can better understand some design aspect of the BIM model. But in terms of the appropriateness and openness, even for the accuracy, the face-to-face communication was better. So one of the reasons why the face-to-face communication provides better quality appropriateness, that actually while we are talking with others, some gesture or our facial expression is quite important. But the avatar, actually at the moment, the virtual avatar cannot reflect our own emotional expression, or it doesn't include it cannot reflect our gesture. So from some verbal communication point of view, there would be some non-verbal cues that can provide some additional information. So virtual communication would be quite limited in terms of this one. So that if for the down the road, maybe in the metaverse, actually the communication with the users is quite important aspect. So mostly we're gonna use some avatar-based communication. So if then it would be quite important to reflect our face, expression, or the gesture in the avatar, so that it can provide some better some openness or the appropriateness during the communication. And the second topic is how immersive virtual training system features would impact some behavioral change for safety. Because recently the VR-based construction safety training is quite common. There are many applications available in the market, and also many researchers have been working on developing some VR-based safety training. And many studies already proved that in terms of providing the safety knowledges, this VR-based training is quite effective. But the problem is, in terms from some safety training point of view, the ultimate goal would be how to change their behavior after the training. Even though they know some knowledge, safety knowledge, if they don't follow what they learned in practice, it will be useless. So that I wanted to evaluate whether VR training can contribute to some sustainable the behavioral change after the completion of some training in the VR environment. So here, so that we developed some conceptual framework here. First of all, on the left side, there are some independent variables regarding the IVR system feature, including the fidelity of the system and the usability. And then as a mediating some variable, which is related to some learning experience, we selected some sense of presence, motivation, and perceived enjoyment, and self-efficacy. And as a dependent variable, we selected learning knowledge, and also the behavioral intention, which means that whether they are willing to change their some safety behavior after completion of the training. Also, we include the satisfaction as an outcome. So based on the conceptual framework, we developed some hypothetical model for the structural equation modeling analysis. And then we did some survey why some participants use the actual the safety training some module. This is the forklift safety training module we developed by collaborating with the University of the South Australia team. This forklift the simulator is provide some safety knowledges, and also while they are using this training, if they are doing something wrong, the system provide immediate alarm so that they can learn. We can provide very hands-on safety training for the forklift operation. So after participants completed this training, we asked some questions regarding the some variables. This is an example of the forklift training. Here you can see some message, and then they can follow the instruction to learn about some forklift operation training. And also, if here you can see some instruction, and if they are doing something wrong here, it provides some alert. And this is the structural, the model, the analysis result. On the left side, the IVR features. In the middle, you can see mediating variable presence, motivation, perceived enjoyment, and the self-efficacy. On the dependent variable, behavioral intention, learning, the knowledge, and the satisfaction. And the green, the lines shows some significant paths. Actually, what we found was that the IVR systems like some fidelity and the usability would be quite important in terms of the sense of presence and the motivation, enjoyment, and self-efficacy during this training. But in terms of the outcome variable, especially the behavior intention and the satisfaction, only the perceived enjoyment would affect these two variables. So in terms of the perceived enjoyment, these virtual reality features provided from this VR training made the safety training more easier for the users, as they will not get bored, because it is a little bit compared to the traditional training. It is quite hands-on training, so that they would be more interested in the getting some training in the VR environment, so that it could increase the perceived enjoyment. And this increase of the perceived enjoyment would be an important role in terms of the behavioral intention, so that even though they complete, after completion of all the training, they would be more willing to change or adopt what they learned in practice if they more enjoyed during the training. This is what we found from this research. And the third topic is impact of the fidelity on the training experience during the IVR-based safety training. Okay, in the previous study, we found that fidelity is very important features that could lead to the higher some training performance. But the fidelity, it is a little bit challenging topic, because first of all, the fidelity of the IVR system is the extent to which the simulator replicates the actual environment. Simply saying whether this IVR system is realistic. But the fidelity to create more to create the virtual environment with a higher fidelity, maybe it would cost more. For example, to make like the ways as Dr. Wei mentioned, actually to create a realistic virtual environment, we need a lot of effort on the rendering, so which may increase the cost for the IVR system development. So the fidelity, simulator fidelity, it is one of the most critical design features, because it would affect learning outcome. Also, it would be related to the cost effectiveness. So the previous study have found that the relationship between the fidelity of the simulator and the learning performance. So here you can see, depending on the expert and the student and novice, actually their learning performance according to the fidelity would be a little bit different. So the one interesting thing is that higher fidelity would not guarantee higher learning performance, especially for the novice student or the less experienced student. so that there would be some moment that some most cost-effective solution would exist, so that understanding the relationship in the fidelity and the learning outcome would be quite important for the most cost-effective the IVR system design. So I wanted to test whether the higher fidelity, first of all, these fidelity requirements could vary depending on the training tasks and the intended learning outcome. This is the reason why the understanding the appropriate fidelity requirement is quite challenging. Again, there would be very complicated relationship between the fidelity and the learning outcome, and also the fidelity requirement could be affected by types of some training tasks. So that I wanted to test whether high fidelity or the low fidelity would be okay. The point is that if the IVR system with a low fidelity can provide similar some learning outcome performance with like some high fidelity simulation, if then maybe we can save some money, because the creating the higher fidelity environment would be quite expensive. So that if we can achieve the same like some training performance with a little bit low fidelity IVR system, maybe it can increase some usability, and also the practitioners would be more willing to use the IVR system because it would be relatively cheap. So to test the impact of the fidelity on some learning experience, especially in terms of sense of the presence and the usability, I also conducted some experimental study. Here, in terms of the interaction fidelity, I created two different VR scene. One is a very high fidelity VR scene. Another one is very low fidelity the VR scene. And also in terms of the interactive devices, I use almost real-like steering wheel, like for the forklift operation, and also as a low fidelity some interactive devices, I just use the keyboard, because using the keyboard also we can control the forklift. And then I conducted some the participants. I split some participants into the 4 different groups, and they were given some really different VR training scenario depending on the level of the fidelity. And here's the result. In terms of the presence, scenario fidelity was quite significant, while the interaction fidelity is not that much significant. Or in terms of the usability, actually I measured the usability using the task completion time, because they were given specific task, and if they complete the task a little bit earlier, it means that they feel like this system is more usable. So in terms of this presence and the task completion time, only scenario fidelity would be quite significant, while the interaction fidelity would be not that much significant. Actually, the interpretation of this result is like this. Okay, for the better some user experience during the VR-based training, creating realistic VR scene is quite important to enhance training some experience. However, the interactive devices, because to interact with between the users and the virtual environment, we need to use some devices like a controller or some keyboard, or some, in this case, some steering wheel. But the different fidelity of these interactive devices would not lead to significant difference in terms of user experience. This means that when we are providing some safety training, actually using the keyboard is okay in terms of the user experience. Maybe just we can use our smartphone to control the VR's this forklift forklift. Even though we are using a little bit the low fidelity devices, it does not affect some learning outcome. So that in practice, maybe we may need to more focus on the creating the realistic VR environment, while maybe we may not need to invest too much money on the interactive devices. And the last topic is investigation of the relationship between the eye movement and the situation awareness during the hazard recognition. Probably we know that the construction is one of the dangerous industry, and one of the critical cause of the construction accident is the failure of the hazard recognition. Sometimes the workers fail to recognize some existing hazards, which can lead to some accident. So I wanted to understand why they fail to recognize the hazard, so that I will use some situational awareness model that is related to some cognitive some processes during the hazard recognition. But understanding the situation awareness, it is not easy. So that I benefited from the VR simulation, because this is some hazard recognition. If we are using the real scene, real environment for some hazard recognition study, it is not easy because we cannot simulate the hazard in the real world environment. But instead, in the virtual environment, we can simulate any types of the hazard in a virtual environment very safely, so that we can understand, we can do some experiment, and also we can understand hazard recognition behavior through some VR simulation. Actually, the situation awareness consists of the three steps: perception of the elements, and then comprehension of the meaning, lastly, the projection of the future status. If we interpret this situation awareness from the hazard recognition point of view, the level 1, the perception of an element, is identifying something in the construction scene. The second level 2 is now we recognize, okay, this is a hazard. The third projection is, okay, even though there are some hazards, if they are a little bit far from us, we may not feel like some dangerous. But for example, there is some equipment on the scene, there is an equipment, but it is coming to me, if then it is quite dangerous situation. So that the projection means that we are able to predict the future status. So I wanted to evaluate hazard recognition behavior from this situation awareness point of view in the level 2 and the level 1 to 3. But the measuring the situation awareness is not easy, because normally previous study have used some survey questionnaire during some simulation, but it could affect some users like some behavior. So I wanted to use some non-invasive measure to measure the situation awareness, which is eye tracking. So eye tracking the data, normally the fixation and the pupil diameter can provide some indirect measurement of the situation awareness, so that I tested the feasibility of using eye tracking data to measure the situation awareness during the hazard recognition behavior. So for this study, we created some different hazard scene in the virtual environment, and then we created some project the subject, and they were asked to identify any existing hazard in the scene. And during this hazard recognition test, eye tracking data was collected using HTC Vive Pro Eye. Okay, this video shows the one example. Here you can see the trajectory of eye. So they are searching the virtual construction scene to identify the hazard. So this is some analysis result based on the eye tracking data. Okay, first, the blue means that level 1, the total duration for the level 1, and then this orange column means that the total duration for the level 2 and the level 3 cognitive processing. Okay, here as you can see here, depending on scene, for example here, they spend they quickly, okay, level 1 means that they identify something on the scene. So in the first scene, they identified something related to the hazard quite quickly, but they spend some time to understand whether this is the actually hazard and also it would affect me. Especially for this one, let's see that this case. Scene 4 was this one. It seems that they spent lots of time on searching for some hazard-related object on the scene. But once they identify something, they quickly recognize, okay, this is a hazard and it could affect me. So here, these two examples tell us that eye tracking data can help us to understand hazard recognition behavior. So depending on the hazard types, maybe sometimes some hazards maybe would not be easily detected. But another hazard, like another types of hazard, maybe can be easily detected, but it would take some time to understand actually they are hazard. So by using this kind of virtual experiment, we can better understand what would be the some factors that would affect some hazard recognition performance. In addition to this data, also we collected some unconscious aspect of the eye movement, especially the pupil diameter. Actually, the pupil diameter is the indirect measures of the unconscious aspect. For example, many studies investigated the role of the pupil diameter during the cognitive task. For example, higher cognitive load could lead to the increase of the pupil diameter, or some emotional arousal could lead to the bigger pupil diameter. So during the experiment, we collected the pupil diameter change. So mostly we can see some increase of the pupil diameter, which means that interesting thing is that, okay, here during the level 1, we didn't observe any significant change of the pupil diameter, but once they recognized the hazard, we observed a significant increase in the hazard. So that for the hazard recognition, actually many studies have used this eye tracking data, and normally they are using, they assume that if they are looking at the hazard, they recognize the hazard. But the problem is, actually, even though we are looking at some hazard in the virtual environment, we would not be able to recognize the hazard because it will take some time in our head to process this information, so that to determine whether this is the actual hazard. So this kind of real simulation with eye tracking data can help us some hazard recognition behavior, especially focusing on the cognitive process. So this understanding of the cognitive process during the hazard recognition can help us how to better design a safety training, especially whether some specific workers would need some increase of specific capability like a perception or some understanding or some projection. So this research can help us some design of the safety training. Okay, this is all about my presentation.